This is a recording for assignment 14 and assignment 15, and these are actually pretty straightforward. So I would estimate maybe 5-10 minutes for the first one, but don't get too confident because the second one's going to get a little bit more difficult again. We're bringing together the two concepts that we've learned in the class. We learned algebra, right, which is when you move something from one side of the equation to the other, and we learned about graphing, and in particular we learned about slope and slope-intercept form. And we're putting those two things together. So how do you use algebra to make a graph? So that's the reason why this is really the capstone of the whole semester. And so we're going to be doing 14 and 15. That's just the definition of what an intercept is. Then number 16 starts to get a little bit more tricky. We're going to use algebra to make a graph over and over and over again, algebra to make a graph. And then finally, the last thing we're going to do is we're going to use algebra to find a slope. All right? So given an equation that's not in mx plus b form, we're going to turn it into mx plus b form so that we can find the slope and the intercept and graph it. So today is all about bringing everything together. It's bringing algebra together with graphing. All right, so let's start with intercepts from a graph. We just need to define what an intercept is. An intercept is the same thing as in football. So here's in football, I've got a quarterback, and he throws the pass out here. And he means to get his football out to this person, but instead somebody gets in the way. And that's called an interception. And there's also cars, like police cars are sometimes called interceptors. So here's a picture of an interceptor. So interceptor. Yeah, they're fast cars, right? Because interceptors, they are able to run into other cars. So that's the reason why police drive them, is because they can catch up with other cars and then run into them. Okay, because an interception is when two things run into each other, like when a police car runs into another car. So that's a really good question. So I'm defining intersection as when two things run into each other. And you can also be an interceptor missile. So an interceptor missile is a missile that you launch to... What would an interceptor missile do? It would hit another missile, yeah. Right, it would hit a missile out of the air. So that's what an interception is. And there's two interceptions that are useful here, and so we need to be specific. The line is going up this way, and it runs into two different things. It runs into this thing here, and it also runs into this thing here. And we need to be specific when we're defining which interception we mean. This is the y-axis. So I call this point the y-intercept because it's where the line runs into the y-axis. And then this line here, this is the x-axis, so this is the x-intercept. Okay, so those are the 2 points where the line runs into the two different axes. And what we were talking about before was slope. So like if you had an equation 3x, plus... So let's do 0.3x plus 0.6 to fit here. Then that would be a line that started at 0.6, and then it would go up 0.3 and sideways 1. And if you had those 2 points, then you could make a line. In other words, this orange line is the line of 0.3x plus 0.6. You need 2 points to make a line. So an alternative strategy to mx plus b form is to use the intercept form, to find this intercept, and then those can be your 2 points to make a line. So that's what we're going to be doing today. Let me clear all this stuff off. The last thing that I need to define, again, this was the y-intercept. So what was the other one? This one here? What's this down here? This is the y-intercept, so this one here is the x-intercept. It's where the line runs into the x-axis. Here's the x-axis. And let's figure out where that happens. Where does that happen? Where does the intercept happen? All right, so when it happens, let's look at x. X is 0.6 here, 0.5, 0.4, 0.3, 0.2, 0.1. What would be here? 0. Where does an intercept happen? It happens, the y-intercept happens when x equals 0. So that's really key. So this is pretty much the most important thing that you're going to learn today. The y-intercept happens when x is equal to 0. And then the other thing, let's count down. 10, 9, 8, 7, 6, 5, 4. When am I going to hit this? 3, 2, 1. Where? Where does that happen? When what is 0? No, not 0.6. When what is 0? When y is, that's what's confusing about it, isn't it? So when y is 0. Okay, so let me write that happen. It's actually kind of backwards. Kind of backwards, isn't it? Okay, when we want the y-intercept, that's when the x-axis is 0, when x is 0, it's backwards. When we want the y-intercept, it's x is 0, and when we want the x-intercept, it's y is 0. Okay, so x-intercept, y is 0. All right, so let's just define these, and I can answer the questions. Where is this point here? What is the coordinate for x? Jasmine, why don't you count down for me? So it goes 6, 5, 4, 3, 2, 1. What's here? 0. Of course it's 0. X is always 0 for the y-intercept. 0, comma, and then what's this point here? It's between 1 and 1.2. Girls, put the phone away. Yes, go ahead. I'm going to push pause. Okay, so a couple of mistakes I saw. Some people were telling me that this point here was 1.1, comma 0. Those people got it reversed. Okay, x is 0, this is x, and this is y. So you need to flip them. So the correct answer should have been 0, comma 1.1. And then there were some other people who were telling me that this was 1. No, 1 would be right here, a little bit below. You want it between 1 and 1.2. Okay, so the first answer is the y-intercept occurs at 0 for x and 1.1 for y, and then the x-intercept is 0.6, negative 0.6 for x. And what's y? Count down with me. 8, 10, 7, 6, 5, 4, 3, 2, 1. Okay, where'd you crash into the x-axis? Peter, what's the y coordinate? 0, thanks, 0. So it's negative 0.6 for x and 0 for y. Okay, and then just to make sure that you know how to enter the answer, Khan Academy splits that up so that you have to put the right thing in the right spot. So the y-intercept would go here, and then the x-intercept would go here. Actually, this is a different example, so let's wrap that up really quick. Okay, please write down write down the word x-intercept, and then fill in that ordered pair, and then write the word y-intercept, and fill in that ordered pair. Okay, the correct answers were, I'm going to start off by telling which one was which. This was, of course, the x-intercept, because that's the x-axis, and this is the y-intercept. Okay, the x-intercept, it occurs when y is 0, and the y-intercept occurs when x is 0. And now that happens at negative 1.5, comma 0, and this is 0, comma negative 6.5. Okay, and then here's how to type that in. The y-intercept is negative 6.5, comma 0, and the x-intercept is 0, comma negative 1.5. Okay, so there's how to type it in. You need to make sure that each blank gets filled in. Did I switch them? Okay, sorry. 0, comma, negative 1.5, negative 1.5, and negative 6.5, comma, I got it, 0.5. What? Did I mess it up again?
This is negative 6.5.
Okay, the y-intercept is negative 6.5. Okay, things are getting closer. And then this is negative 1.5. Okay.
All right. I'll leave this up here.
All right, so if you would please, this is now the next of the two assignments. So it's a little bit more complicated. And in this case, I'm going to use a graphic organizer in which I find the y-intercept on the left-hand side and the x-intercept on the right-hand side. So first I'm going to figure out which one is which. So let's see, the y-intercept, I know that x is 0. And for the x-intercept, I know that y is 0. Now I can use that information to figure out the other variable. So in this case, my equation is 3 times x plus 2 times y equals 5. and I'm about to evaluate. Leticia, what's the word evaluate? What do I do here? What do I replace? Okay, take x and replace it with the number 0. Now, 3 times 0 is just 0, so I would prefer if you think of it as this term goes away completely and you never see it again. There are some people that like to write 3 times 0 makes 0 this way, but it's kind of a waste of time. Because if you subtract 0 from both sides, nothing changes. So what I'd like you to do is start thinking of when I replace the x with 0, this term goes away completely. And I'm just left with the 2 times y equals 5. Now that's an algebra problem. I only have one variable, nothing wrong. What's the opposite of times 2?
Divide by 2.
Okay, put divide by 2 to both sides, cancel your opposites. Y is by itself. I have succeeded in solving for the y-intercept.
So, mister, you don't put 0 for 2y?
What did I replace? That's a good question. What did I replace in the first step, the evaluate step? No, I didn't replace the 3x. I replaced x with 0. Now 3 times 0 went away, and I was left with the 2 and the y.
So you only replace the x?
Okay, that's a good point. If you want the y-intercept, you replace x with 0, and if you want the x-intercept, you replace y with 0.
Okay.
Yeah, that's what I meant about it being kind of backwards. Letitia, please follow along. So I'm going to put 5 halves here, and I'm going to let you guys figure this one out for yourself on one on your board. Okay, my first step, I saw a lot of people getting confused. You do not do anything to start with. Do nothing. Take the equation and write it down. Girls, stop talking, please. Take this equation and write it down again. So that's just the information you know so far. And then I can replace y with 0, which means that this term goes away because 2 times 0 is 0. And the equation I'm left with is 3x equals 5. I can divide both sides by 3, and I'm left with my solution. X is 5 divided by 3, which is a number that's more than 1 but less than 2. Close your computers, please. I got one more that I'd like to do, but I'll pause there for a second. So in this equation, I can replace x with 0, so I'm going to erase that x and do nothing else to the equation. Now I could put in a 0 here if you want me to, so I'm going to put 0 here for x. And then I've got an algebra problem. Now I'm probably going to have to scroll up to get extra room, but the first step here is 0 minus 6. So 0 minus 6 is negative 6. So instead of 7 times, it's now, by the order of operations, it's 7 times negative 6. So that's y minus 4 equals 7 times negative 6. And let me scroll this up like I said I would. Okay, and 7 times negative 6, again by order of operations, is negative how many? Negative 42. And then last step, according to algebra, how do I get y by itself? No, it already is minus. Not divide. It's already minus 4. Add 4. The opposite of minus is plus to both sides. Big long line that means equals. Cancel your opposites. You've solved for y. Y is equal to, and then these are opposite, negative 38. You can put a box around your answer. And then I need to scroll it back. Okay, so let me scroll back here so that I can, I'm going to upload this if you're trying to catch up. So in a second, this is going to be online. So I can put in for the y-intercept here, when x was 0, y was negative 38. And then I'm going to very quickly do the other side. I start by writing just the equation, y minus 4 equals 7 times x minus 6. I can replace the y with 0, and I'm left with an algebra equation. Negative 4 equals 7 times x minus 6. You've been asking me forever what distribute is good for. It's good for this. You distribute the 7 to the x and to the 6. I wind up with 7x minus 6 times 7 is 42. You have to multiply both things by this 7. Okay, the opposite of minus 42 is plus 42.